So I was talking about a retail store that basically was very future-looking, saw that there's a huge future in doing online sales. If you haven't guessed who the company is yet, it might help to know that if you spent part of their promo, if you spent over $100 in your order online, you'd get a free Tickle Me Elmo doll. Huh? So if you think about it, like this was before the iPhone. The iPhone wasn't out yet. This was before most of us shopped online. I hadn't shopped online back then yet. And so they built an environment with 10 times more servers, more capacity than they had ever had in traffic. Fortunately and unfortunately for them, their marketing team drove more than 10 times the number of people to their website. If you haven't guessed, Toys R Us was very future-looking back then, before they went bankrupt. But the thing is, it taught us and the whole industry something, which is they were down for 2 weeks. They needed to buy more servers and add them and stuff. And so the problem in doing these things is that we need capacity sitting there waiting for us to use. And that's really why we're all here today, right? The capacity that a hyperscale cloud brings with servers sitting there that we can scale out and handle internet scale loads. So that's what we've built at AWS, right? We have this large worldwide network of servers and regions and availability zones to give this. Well, it turns out that this can be used for our enterprise workloads too. And that's what this session is going to be about, is about taking this hyperscale cloud and leveraging it for enterprise workloads. Specifically, we'll talk a lot about Microsoft workloads because in the enterprise, 70% of the servers on premises are Windows, Microsoft workloads. But well, I'll get into it and show you what we do there. But that's the really neat thing here. Now, another thing, people often will ask when they haven't known cloud, they just, you know the buzzword cloud. Cloud, all right. So I'm going to take my app that performs poorly, and I'm going to fix it all by just putting it in the cloud. Anybody ever hear that? A few of you, definitely. I've certainly heard that. And cloud's not magic. It's the same stuff that we've done all along with computers, networks, all that kind of stuff. Many of us haven't had budget to do some of these things. And some of us didn't think about doing some of these things. The closest we have to magic in AWS, in my opinion, you may disagree, but is the availability zone. Availability zones are awesome. What we have is we have 2 different data centers, right? One AZ, one AZ. Those are 2 different data centers or clusters of data centers. And between them, we have very low latency. Generally, it's under 1 millisecond, but generally in single-digit millisecond response time. So that is a huge, huge change and gives me the ability to do things that business groups have asked me to do for years. I've had business groups come and, when I ask, okay, for your app, what's your RPO, RTO? And they go, what's that? Recovery point objective, recovery time objective. One is about how much data loss can you use, when we go from tape, and then any data loss kind of stuff. And then the other one is, how soon do you have to have it back up and running if we have a catastrophic failure? Can I take an hour, a week, a month? And the answer is always the same. Well, I want 0 data loss, and I want no downtime. And for me, that was fun, right? Okay, so let me buy a SAN here and a SAN here and the $50,000 sync software. And then they look at me, but you haven't even bought a server yet, and you're 10 times more than my budget, or even more, right? So we generally didn't build those things. NASDAQ maybe did, or some of the big companies that needed that. But most of us did not. And so what availability zones bring us is this ability to really take and leverage this server infrastructure. I mean, we'll call it cloud today, but they're servers. They're just servers that you're using somewhere else that are API driven. That's the other magic behind it. And if I look at this 3-tier architecture, there's a ton of nice things here for me. In the Microsoft workload space, a lot of times you have a database in the back end. And so in this design, I'm showing an RDS SQL backend, but it doesn't matter. I've got 2 servers, two Microsoft SQL servers in 2 different data centers that's doing synchronous communication instead of async. And what that means is when my application goes and writes to the disk and makes a commit, it sends that over to the other database as well, waits for them both to acknowledge that it received it and has it, and then my app moves on. And the reason we didn't do this generally when we built our own data centers in the past is generally our latency between data centers was 50, 80 milliseconds. You know, and here we're single-digit millisecond or sub 1 second even sometimes. So that's an experience that my customer doesn't mind, right? They're not waiting for the app to write the data and save it. So I can do this with 2 servers for the database, whereas traditionally I would actually have 3. I'd have 2 in a local data center in different racks in case someone kicked the plug out of the rack. Nobody worked in a data center? You don't have plugs. Anyway, so as far as that aspect, I'd have 3 of them. That's 3 licenses, it's 3 servers, all that stuff. And I would do the synchronous in that one data center, and then I would do async to the remote data center. So if there was a catastrophic failure and a data center loss, I wouldn't lose all of my data. I would just lose a little tiny bit of it, possibly none. And I could have this high availability. So here, it's other benefits too. When we have this design, to fail over to another data center, usually that's a manual failover. This is automatic. And if you're using like our RDS managed service, not only does it automatically fail over, but that server that died over here, it automatically creates a new one and rebuilds it, which is otherwise, for all of us, a manual task. So that's just the database section. And then we move up to the next tier. If we do the application tier or the web server tier, not all applications can scale out, right? Some of them can only run one copy. But if they can scale out, I can even lower costs, right? I can take my Windows servers and my applications on there, instead of running the big instance that they need, at the top time of the day, maybe the top time of the year, I have to purchase my hardware for that on premises. Well, here I'm able to do it where I go and I take small servers and I run 2 of them, one in each, AZ, because in the middle of the night we've got 10, 20, 30, 50, 100 users hitting it. Doesn't need that kind of load. But then, come 8 o'clock, I can automatically add more servers to it, scale it out so that it can handle the 1,000, 2,000, or whatever number of users are hitting it, whatever that app needs. And then in addition to not only doing it by time, I can do it on metric of how much network traffic or how much CPU load is there, and I can add even more servers to it. So it lets us take a lot of our old applications without rewriting them and lower our costs and get scale. So that's, as well as the high availability, right? So that is really, I think, the magic in our cloud is this availability zone concept. In addition to the high availability and that aspect, I lost my train of thought exactly where I was going with that. But it's awesome. We'll just leave it at that. So for my enterprise workloads, I leverage this exact same thing, and what I do is I use it as a remote data center. So just like I was doing a colo, right? I put in either a VPN, or I put in a direct connect, which is a linked line to it. So I have my regular corporate environment. Now, if I don't have a corporate environment, I'm starting from scratch, I don't have to do this, and there's more things I can do. I can use managed AD and all kinds of other aspects. But for most of the enterprises out there, we're going to take our on-premises Active Directory, and we're just going to extend it just as we would have done if we were going into a colo. We're going to spin up a VM and put a domain controller out there. Now, the nice thing in the AZs is I can have one site across those 2 AZs, right? From a domain controller perspective, Microsoft Active Directory, basically anything over 15 milliseconds requires a separate site. Since we're under 15 milliseconds, this can all be one site. But having 2 servers out there is not a bad idea, because then I have that redundancy. They can hit local Active Directory for the services that need Active Directory. I can patch, and as long as I only bring one down while the other one's up, there's absolutely 0 downtime for that, right, from the Active Directory perspective. Again, we're showing the same SQL server with always-on availability groups of that synchronization, and we can do that scale out. The next left side there, I've got the public section. Maybe you use that, maybe you don't. There is no right way to do it as far as setting up your network, setting up your environment, doing your servers. There are wrong ways to do it. There are things we find that fail, but there's not a right way to do it. Different business cases require different things. Maybe we want, at our business, all of our traffic going through the corporate data center. And so these are private networks. They never hit the internet. Everything goes through that VPN or direct connect and out our data center that we have on premises and uses that internet connection. Maybe we want to use the internet connection at AWS because it's kind of nice and fast and we could use that. So it depends on the business of whether or not that complete design is there. But that multi-AZ design, and we're showing 2 here. Usually you do 3, right? So you got the 2 that you put all your services in, and then you have your third availability zone as the witness area, right? So that we can watch for who's up and running. Like if a data center does go down, well, which one's down? You vote, and when you've got 2 votes, that's the one that wins. So that's why the third AZ comes into play. There is another thing, the VPC endpoint at the top here. There's a lot of times you need to build something that hits a compliance need. And a lot of times that compliance may say, even if it is still inside AWS, it's still hitting a public network instead of a completely private network, right? So as I go to S3 storage, for example, it doesn't go outside of AWS or even outside that data center necessarily, but it may go onto a shared network and that may break a compliance. So we have VPC endpoints that can be done to keep everything enclosed into a private network. And so that's something that is very important to some of the enterprise customers. But the reason I'm going through this is when I'm running enterprise workloads in AWS, this design and the other things I'm going to show you give you the flexibility to do all kinds of things as you go forward. Not only is it great to run your current workload from the lift and shift perspective, but it gives you flexibility to do all kinds of future designs, and we'll talk about those. But we have lots of white papers and information on that design I just mentioned with the multi-AZ. We call it well-architected. Now, I've done audits and work with some different partners. One of the partners who actually failed, I should add, when they were talking about well-architected, we were looking at their designs, and I'm like, well, is it well-architected? And they're like, oh, yeah. And what they meant was, oh, yeah, we built it good. Well-architected is a pattern in practice, right? These are steps that you can follow to do the multi-AZ, to do these things. And when you think about the AWS higher-end services, because as we talked about, everything's just computers, right? And when we get to the higher-end services, that's really just computers with automation. It's virtual machines, and whether I'm going to an RDS managed SQL box or a managed AD, or whether I'm going to a higher-end service where I submit a text file and it submits back an audio file of that text, or I submit an audio file and it submits back, the text of it, or I give it a picture and it sends me, hey, we think that's a person sitting in a field, and we're this confident of it. Those are all just automation pieces. Anyway, of the 160 plus services, and that number's probably got to change after this week, all of our services are built with a well-architected framework with a multi-AD design approach, which is the only way to get a really good availability. So I highly recommend you look at that, well-architected white papers, as you look at designing your networks and your infrastructure for your enterprise apps. Now, the other piece I recommend is doing a multi-VPC approach. And with that, a multi-account approach as well. And here's why. I could have us all go, and everybody in this room, we can log into my account and we can start building stuff. But I'm not going to know what that VM's for, or that VM. Like, let's say I put my CRM app next to my HR app all in the same account. And then, we're a bigger company, and the team that works on the HR app is different than the one that works in the CRM app. Let's say there's a S3 bucket created. Which team created it, and can I delete it? Is it going to cause production problems? There's tagging to get around that. But to me, I want it super simple. And to keep it clean and super simple, I use multiple accounts. And so what I'll have is a shared account for shared services. I can put my Active Directory in there, and everybody can leverage that. But then I'll use VPC peering to go to other subnets, and I'll have other environments, so not only a different VPC, but a different account. When I log into there, it's only the HR data. And as I wrote on the, built on the bottom box, you know, I built the 2 AZs. I would expect a multi-AZ approach makes sense. There are times that a multi-AZ approach doesn't make sense, and that's when you want to do it as cheap, as least expensive as possible. Because when you go to a multi-AZ, you're about doubling your cost. Still, that's way less than what it would have been with those SANs back in the day. But if you don't need high availability, if you don't care if it takes a month to get that app back up and running, you know, that's in jest too. It could take hours or whatever. But if you don't need that immediate uptime, a single AZ may make sense. But definitely, we're still doing multi-AZ on the shared services. We're doing multi-AZ in our applications. And we peer them and keep those accounts clean. And so the other side of it, we have the corporate data center. It's just a regular connection as we would do to any data center. So one of these ways that we take control and manage these things is with organizations. AWS organizations is an ability for me to take an account and then create sub-accounts underneath it, or I can invite them to join that account. And this one account is the only one that gets billed. Everything else flows up to it. And so that way, it makes it easy. I get one bill, I have multiple accounts, and then I create accounts for different people, devs and that kind of stuff. I create accounts for dev test, I create accounts for production, and I have things separate and clean. And so when I log into one, you know, it's very simple to figure out what's going on, or a lot more simple to figure out what's going on. The other side of it is I can easily give people access to it and restrict access to it, because in production, you may only want a couple people to have access to it. You may want no one to have access to it and have a CI/CD pipeline push all of your things into production. All that stuff is something that we can't cover in an hour. It's a lot more complex, and you look at your business and what you need to do there. But the organizations is a huge, nice piece for not only the billing, but for managing those accounts to do your multi-applications. So here in this design, we're looking at multiple applications, not only from an aspect of, all right, I've got my production, I've got my pre-production, I've got my teams that build and all that stuff in those multiple accounts. I've also got things like an account for monitoring, and I can set policies on those accounts. And I can tell every account within there that I build, you're going to have to send CloudWatch alarms to this main account for logging and for security, right? And so, you know, I can take all my Windows Server logs then, and I can have that go all to a centralized spot that maybe the security group is over, or maybe at a smaller company, the IT group is over. But we can also restrict who has access to that, right? One of the things that a hacker will do, or a disruptive, angry employee, is they will do their dirty work to you, and then they will go and delete the logs so you don't know they did it, right? That's a kind of 101 standard practice for hackers. But if you're using this type of approach, once those events are kicked off and sent to the other account, that other account is segmented and they don't have access to it. So you never lose that information for the post-mortem of how did we get hacked, what happened, who do we send to jail, all that kind of stuff. So that's a good design approach. With that, let's actually take a look at how that works a little bit. I want to switch over to my demo machine. And so here I'm logged into an account. And in this account, if I switch the services and go to what's called AWS Organizations, in the AWS Organizations section, I've got a bunch of sub-accounts. I've got my main root account right here. So let's try that. Is that any better? No. We have an echo going on? All right, fantastic. Thank you in the back. So basically we have multiple accounts here. If I want to add an account, I said create an account. I can either invite an account that already exists to have them join if it's a standalone account, or I can create a new one. And I can go create an account like, let's call this the CRM app. I'll give it an email. For me, I'm going to do WDR plus CRM. It's got to be a valid email. And then I create. And so that's going to create another account here for me. This one is creating, it'll probably be up in about 60 seconds, unless I hit some limit and can't create more. But I created another one last night called HR app. And we're going to play with that one in a second. As I go into organization accounts, I have the accounts in a tree view here. I have my CRM app, the one we just created here, that account. I also have this HR app. We'll move the HR one first. We'll see if the CRM one's created and I can move that too. But I'm going to take this app and I want to move that to production, right? So basically what I do is I select it, I hit move, I drop it into the production organizational unit to an OU. So what does that do? That puts that in production. I've got my developer accounts in the developer OU, and I've got multiple accounts in there. By putting it in an OU, I can attach policies to the OU. Whatever account goes into there gets different control around it. So for example, I can do to every account, you're going to all do CloudWatch logs and I'll ship it to the main CloudWatch environment. But then for like this OU here for production, I can set certain things on it. One of the things at AWS, my accounts have only one restriction set on them. So I'm under the AWS organization, and my company accounts will not let me create DNS names. That's the only thing, because they didn't want all of our employees going and saying, hey, you know what'd be cool is Brian.com, AWSBrian.com, this.com. And just, you can imagine your employees might, if they were free to do whatever they wanted, build a lot of DNS names. So that's been restricted. Everything else is open. Now, sometimes you may want to restrict more things and say you can only spin up small instance sizes because some of our instance sizes, you can scale up. So we talked about those poorly written applications. Bringing them to cloud, sometimes you can make them work okay because there's instances larger than this, but I know the largest one I've played with is 4 terabytes of RAM and 128 vCPUs. However, that thing costs a fair amount of money on demand. I think that was up around $32 or something an hour. So you might not want your devs to be able to create any size server that they can. If they need that, that's one thing. If they're just doing it because it's not their money, that's another thing. So these ability to set these controls is hugely important. Next, I want to show you in the VPC section, the peering is rather simple. It's traditional networking stuff. The only thing you have to pay attention to really is the IP address ranges, and they have to be routed. You have to be able to route, right? You can't use the same IP address range. So if we take a look at, I have a VPC here, and it's a 172 range with 65,000 addresses in it, /16. I want to connect that up not only to the other apps. I just built the CRM app. I want to build it to the HR app. What I do is I have to go to peering connections. And I do have one peer already set up. I'm going to another dev account. But let's say this other subnet here is my shared services where I have Active Directory and all that stuff. So I create a peering session, and I give it a name. So I'll call this one HR app because I'm going to connect up to my HR application. And the network I'm using is my local network, which we're going to call my shared services area. And then I need to connect up to a different account. So I'm connecting up to another account. Now I wrote this down because I need the account number, which the account number is right here. So I put that account number in, and then I have to connect up to the VPC name, that virtual private cloud, the network name. And that's, for that one, I'm going to connect up to this network here. So I put those two fields in, and I create the peering. What it does is it sends a request out to that other account, because I may not have access to that other account, but on that other account, they get a request, and they have to accept it. So right now, for the HR application, it's a pending thing. And so I'm going to switch over to that other account. There's two ways to do it that are easy. I mean, one, I could log out and log in. That's one way to do it. Another thing I can do is by basically switching roles, I can switch over to it if I'm in the organizational owner role, the root account, and that's what I'm going to do here. And then I'll show you another way that is probably makes more sense in your enterprise to do it. But that is this account here. So I switch to it, and now I'm in that account. And so it has a peering request here. And if I take, it's selected, so if I take an action and I accept the request, yes, I accept. Now it just created that peer, and now those two networks are connected, the routes are established, the routing table is updated, and my networks, my app, the HR app, can basically talk to Active Directory and whatever it needs to in that section. And if I want to go back to the main account, I can switch back to that main account by going back to that account. So that's one way to use the multiple accounts. More likely way that you would use is you would use it with a single sign-on. So AWS single sign-on sets up an environment where I can either leverage Active Directory or some other directory you have, or you can do your own single sign-on directory here, where I create my users for the company, and then I give them access to different accounts and control that. When they log in, they get a view. Let's see if I'm logged in still. Nope. So I log in, and let's not save that. And so I've got a couple different apps here. The AWS accounts is the one I'm thinking of. And when I hit that, I've got two different accounts that I've given this user access to. If I expand that, I can go to the management console, and I'll start the management console for that app, or I can go to the command line. Now, I won't show you the command line one because you guys use flash photography, and you'll have my keys, and I'll have to go delete that account right away, or you'll be Bitcoin mining me. But if I hit management console, it just starts the management console under that account. Right? So that's another really nice feature to use. So the AWS single sign-on gives me the access from an infrastructure management perspective that's very useful as I go and move my things over to AWS to manage multiple accounts and make that easy. All right. And if I wanted to log into the other one, I would go here and expand that, hit the management console there, and it's going to sign me out of this one, but log me into this one. And I could have 100 accounts there. There's no limit in that regard. All right. So when I set these up, there's some other nice things we can do, which is we can set up an account vending machine. This is an area where we can go and easily have accounts created. People can request accounts and have new accounts spun up. Because if we're going to have people create a different account and a different VPC to run the CRM app and the HR app and the other app and the next app, having a person be the bottleneck of I have to create these for you is probably not the easiest way to go. Account vending machines are a great way to go, and you can use policies of who's allowed to request what type of accounts, as well as the automatic creation and handing out of those accounts, as well as auditing. There's another tool that we have that sets all of this up automatically on a fresh account called AWS Control Tower. So these things that I'm showing, we've kind of learned over time, make it cleaner and easier to set up enterprise environments. And with that knowledge, we set up, last year we released this Control Tower, which sets it up for you, which makes it a lot easier to have the best practice designs, the security groups, the different things set up that it's already done for you. So that's definitely something to look at as you go into that. So now with that, what I'm going to do is the gentlemen who've been sitting here nicely next to me are from Comcast. And they've done some work with moving enterprise applications over to AWS. And I'm going to hand it over to Will and Amish, and they're going to talk about what they've built and what they've done.
So we heard a lot about Windows architecture, and one of the big challenges that we faced at Comcast with a very large Windows footprint was how do we bring all this information to one control plane where we could query it and run analytics at a large scale. Some of the challenges we were facing was we wanted to make a lightweight agent that we could use and deploy, and we could move from the pool to a push model. So all this information could go into one place, and we have access to unlimited storage at a reasonable cost. As many of you guys know, Windows Logs events not only generate security events, but we wanted to capture every event so we could give that back to multiple divisions so they could use that to enhance their Windows footprint operational efficiencies, and derive insights that they weren't usually able to get with their traditional logging and monitoring tools. Part of this entire process required us to find a platform that allowed us to scale at a reasonable cost, but also allow access control. We did not want folks to see other people's logs, but we also wanted to provide them the ability to use any tool that they found necessary to deliver the information where it was needed to make decisions at a very rapid pace. Our previous tool was very much a vendor lock product that we decided at this time we wanted to open it all up and go with agent that many folks could access. Will later describe how we described the architecture to build this for many different purposes. One of the things that we really wanted to emphasize with our rollout was that we're consistent coverage across domain controllers as well as Windows servers. So this really helped us standardize the way we're doing Windows log collection across the entire enterprise without constantly worrying about which tool and what version and what product was deployed, and then maintaining the ETL jobs in our data lake to really derive value from the information. I'm going to hand it over to Will, and he'll walk through some of the architecture.
Can you guys hear me okay? I don't know if okay, cool. So kind of to walk you through the general architecture, the majority of the Windows infrastructure that we're looking to target is our on-prem. And in order to access sort of the larger benefits that we get by moving to a cloud platform, so you kind of see at the center of the diagram, we have S3 as sort of the crux of most of this. We began with WinLogBeat. We had tested a couple systems that sort of fit a similar need, but we found that WinLogBeat kind of really hit the kind of sweet spot that we operate with as a team, where it embraces open source. WinLogBeat is a completely free open source tool that's produced by Elastic that talks to the Windows event log. And by talking to the Windows event log, you then kind of get a very rich overview of the system. So this kind of a model is useful if you monitor one server or 10,000, because you can drill down all the way to an individual event ID within the Windows security auditing subsystem, and then actually push those events out of the host. So, you can then kind of aggregate them in a logging pipe. So you kind of see after the WinLogBeat section of the architecture diagram, we have Backwaters. Backwaters is our own log transportation solution that helps to transport these events from the on-prem infrastructure to AWS or to other cloud platforms. But we're mostly going to talk about AWS since that's where we are. It leverages a direct connect to connect the on-prem infrastructure to AWS and lands that data that we're caring about in S3. However, what's really important to note is you can land whatever you want in S3. They could be individual log files. You could actually just continue to throw your log files in the root of an S3 bucket, but that's going to be very not useful to most instances where you have scale involved. So utilizing WinLogBeat, you get the ability to extract metadata from the Windows event log that help you organize your Windows events. So you can utilize the natural structure of Windows event logs when you're looking at it in the event viewer, where you see that, okay, I have my Windows events, I have my system events, my security auditing events, and finally you get to the 4769 events that you've actually been caring about as an incident responder. And so you can utilize that associated context in S3 to actually template partitions within S3. And utilizing those partitions allow you, as sort of the administrator of this platform, to be able to not only have really rigorous access control for, say for example, you have systems administrators that don't need access to specific Windows events. There might be some proprietary Windows events that a vendor might use that only the incident response folks might need for some privacy regulation. Hypothetical example. But you could then construct policies with S3 to say only incident responders can look at this data, or only system administrators can look at this data. However, it's not without its own associated problems that can crop up. And that's where S3 batch operations can really, really help you. So if you've worked with a Hadoop-like system, S3 batch operations is way simpler, but it's sort of similar, where you can utilize S3 batch operations to basically map your whole S3 bucket, and then utilize lambdas to potentially categorize data, or what we mostly used it for was detecting corrupt data because failures happen, and being able to actually clean that up. So then that way you don't impact your downstream systems. Or when you do find impacts, or you do find that you encounter problems, you can address them, because you kind of need to plan for those failure scenarios in this model. But assuming that we have progressed to this point and there are no problems, and your information is laid out based according to its natural structure, you can then use AWS native services to perform analytics. So you can utilize a service like Glue to traverse these data sets in their natural form to generate schemas. And then those schemas you can then query in Athena. And you could easily pull together a SQL query that gets you a histogram of computer names that might have been sort of central to account lockouts. That's a very common use case we end up having to help facilitate because of the size of the Comcast environment and sort of our nature of doing this log collection. We can help facilitate those teams be a lot more effective. Other things that you can use Glue for is potentially doing roll-ups for really, really talkative events. We found that there were a certain set of servers that were logging all TCP connections. Well, in this environment, that can get very talkative. So you can utilize Glue to perform an aggregate of that. So you can, instead of dealing with 10,000 events, you're now dealing with 100 and trying to distill down those connections to the things that are interesting, things that might not be NATed addresses, maybe they're external addresses. So you might only want to nail that down to traffic that's egressing your network. And so finally, this is still an ongoing project. It is still a service we are intending to render within the company. And so improvements that we'd like to roll out are working through the process of doing self-service onboarding. We typically would deploy WinLogBeat by way of SCCM. There's a package that would then get distributed to the rest of the infrastructure. SCCM is actually a service not managed by our team, but when you're working at the size of a company like Comcast, there will inevitably be situations where you need to help teams that might not be using SCCM. They might be using some other system because they are a brand new subsidiary. And it would be really great if we could kind of get out of their way with integrating into this infrastructure, because nobody's going to really have the mind that like, oh, I don't want to send my logs to security because I'm going to do it myself. Like, you totally could, but we can help you, and that's sort of the role of our team, is to be able to help all of those subsidiaries. And finally, or I guess not finally, it would be really nice if we could adjust the configuration files without having to modify SCCM packages. So utilizing some sort of system to generate the WinLogBeat configs when we determine like, oh, we actually need to talk to this separate Windows event log. Because typically in WinLogBeat, you would say, I want the security events, I might want these specific event IDs, and asking the administrators of SCCM to push a new package because we determine that there is a certain Windows event log that we want to be able to talk to. It's just reducing another point of friction, because you want to be able to not get in the way of these teams, and you want to be able to accelerate them and allow them to move faster. Having a customer-facing metadata service would be really handy for things like the account lockout scenario, where that's not necessarily something that is a super private thing. It might be the kind of thing where we want to make that information more available to the rest of the company. And that's something you can easily do with this architecture by potentially leveraging something like API Gateway on top of Athena or some other sort of service that performs those queries and stores that information and just renders it in an API endpoint. Because there have been a lot of requests we've gotten from a lot of DevOps folks that are like, it would be great if you could just give us an API route that's like all of our locked out accounts. And finally, self-service alerting pipelines. So since we are doing this centralized log collection, you don't really want to open up that account to everybody, kind of like what Brian was touching on with, oh, what's that S3 bucket, what's that EC2 instance? So it would be really nice if we were able to provide a system where owners of systems that are logging to us could configure alerts. So then that way, they are the domain experts on their systems, and they could help provide that associated context to us to allow us to better protect their systems, because it helps us save time by not having to kind of like digest a lot of the internal complexity, and they can help us better protect them. And I will pass it back to Brian to go over migration and modernization.
Thank you, Mish, and thank you, Will. You guys caught our beginning, at the beginning, you caught our discussion of me helping my son change his tires. I wish you would have heard the earlier conversation, not the one right before that, where Amish talked about he changed a fuel pump this weekend in a car, in a Ford
Taurus. 2003 Ford Taurus.
Yeah. So that wasn't the discussion. The discussion was before that, when we were talking about logging. We were talking about, I had dinner last night with Jordan. You guys all know Jordan, right? I had dinner with Jordan, who works at a SaaS provider. So he was talking about they have this large SaaS environment, and it's not a matter of when system degradation happens. It's a matter of when it happens, not if it happens, right? Systems will degrade at some point. And the on-call pagers are rather expensive and all that stuff. So they basically have a system set up where it takes the CloudWatch logs, it looks at system degradation and other issues, and then it's basically entering that and then paging people. And they're using the thing from LinkedIn. They've open sourced two things, and I'm drawing a blank on them. Will, I know you know what they are.
Iris?
Is Iris. Yeah, Iris
yeah.
was one. And so this is the conversation you missed earlier. That would have been nice. If we were just talking about that before the start, it would have been perfect. So Iris, and then the other piece is like call something or whatever. But it's a pager system with a whole basically UI that gives you the ability to set who's on call when. And so they've taken that open source project from LinkedIn that everybody can get off of GitHub, and then linked that into their environment. Linked that in, I didn't do that on purpose. Where they're able to get all these lists of problems and where they're handled, and the response is automatically paging out and whether it's taken care of. So that's a really cool use case that you might want to do to manage your environment. Switch over to this. All right, fantastic. So if we look at a lot of the idea of what people start with is the lift and shift. We're basically taking we're taking on-premises and moving it into the cloud. And generally, customers, we're seeing them save 36, 37% by doing that, just on the fact of switches and network cables and data centers and servers. They cost a lot of money, and hard drives. And we're able to do it at scale, so we have a lower cost at that, and we're able to pass a lot of that on. Sometimes, you want either more cost or you're not hitting that savings that you want. And so it's about right sizing, because on premises, we need to buy the server for as large as it's ever going to be. And if you've ever went and ordered your server, you kind of take a swag at, I think it'll need to be this big. And then, I don't know, everybody's got their own thing. Do you then double it, right? Because what you can't do is you can't go back to the boss and say, I guessed wrong on the server size. And we need to drop another $10,000 on a server, or $50,000 on a server, whatever the size server needs to be. So it's easy in cloud to right size. Now, it does create downtime, right? You got 5 minutes of downtime as you change that size of the instance. But right sizing is one of the first steps people do. And we post this under the term modernization quite often. But that lift and shift can give us stuff. The right sizing can give us stuff. If we can get to that horizontal scalability, that helps improve those environments. Using decentralized logging can help improve. There's other things that we aren't going into, like Systems Manager, which can do your management and patching of your servers that we offer. But then as we go down that line, as we look, what we're trying to get to is truly optimized nirvana, right? that's the SaaS app actually, right? So this is actually going more towards the, for people who build the SaaS app, but going to serverless or a managed server, right? So the way I kind of do my designs is I start at, if I got a greenfield app, can I go serverless? Is there any reason why serverless doesn't work? Is there any reason why serverless would be more expensive? Because usually it's way less expensive by 1,000 times, but not always. And then the next thing I look at is, can I do, for the database, can I do open source? Can I migrate that stuff? Because that's usually about 10 times less expensive if I can get rid of that license. Another thing I look at is, all right, if I'm going and I can't do some of that, how about a serverless container? If I do containers, I like to keep them in their own account still, like we talked about. If I have to put those in the same account, right, because I built my server, basically my container, Docker container environment, I've got host servers I've purchased, and I'm running at least 2, probably 3, maybe even a larger cloud. Then there's probably the CRM app running next to the HR app, running all this stuff. And again, I get back to that, I want it simple, and I don't want spaghetti that I have to pull apart and try to understand, because there's things that pull me away from that for a little while. When I come back to it, I want it easy to understand. And so as Fargate, I'm assuming I'm not announcing that, Fargate, so it's on ECS, but we just announced, I believe, that it's also on EKS, gives me a container or a serverless environment to go run those Docker containers. And so getting to those areas, that's kind of the nirvana to get truly optimized. It then gets me the ability to do stuff where I can do changes in the middle of production. We have one customer who has said to do changes 30,000 times a day of their application. Most of the traditional Windows workloads I've come through do 1 to 2 changes of an application a year. So even getting down to once a week is amazing. But being able to change and make changes in the middle of production is even better than having to do it. I used to do a lot of work over Christmas and over other holidays because that's when we could have downtime. No longer do we have to do that. That's awesome. So getting to the truly optimized cloud environment is really a nice thing to have. Now, when we look at rethinking compute and storage, as I mentioned, we go and we move it to virtual machines, we lift and shift it and put it into the hyperscale cloud, right? We get some benefits. We can do some changes that get even more benefits, maybe scale out, maybe smaller instances and some of that. Multi-AZ to high availability. But then there's the opportunity to go to containers with no code change usually. And then we can get some benefits there, but it's higher effort. And if we go and refactor the app, rewrite it, we can get to serverless generally. But that's a lot more work, it's a lot more cost or effort. And so as we look at these, there's pros and cons to each. So if I rehost, right, very simple, very quick, I can pick it up, move it in. If it works on a virtual machine on premises, it'll work in a virtual machine in the AWS cloud. But I'm missing most of the benefits, right? I still have to have a scheduled downtime to do a patch and a reboot of the server. I still have, the aspect of I'm paying full licenses. I'm paying for a server in the middle of the night that's running and doing nothing because no one's hitting it, or one person, right? So you lose some of that. But there are a few things we can do, like I mentioned, with smaller instances, scale out, that if we go to replatforming and taking that virtual machine, doing containers, or going to a managed environment like FSX file shares or managed Active Directory and some of those things, I can realize some of the benefits, reducing my management needs. I don't have to patch. I don't have to worry about those things. Sometimes it requires rework to do those things, but I can get a bit more benefit. And then the last opportunity is to refactor and to look at serverless for our .NET apps, to go to containers with .NET. And there's 2 ways we can go there. On the slide, I'm calling out going to Linux. Linux containers with .NET Core are the way to go. As a matter of fact, yesterday, you may have missed the news because you're at AWS. It's all about AWS, but Microsoft just released .NET Core 3.1 yesterday. And so .NET Core 3.1 is a huge milestone because they've got all the APIs and things they plan to put in. So as hard as it is today to move from .NET Framework to .NET Core, it probably won't get a lot easier as you wait. So that's a huge milestone. And .NET Core runs on both Windows and Linux. Running on Linux, not only do you reduce costs, but the container management, the containers are a lot more mature. It's been running on Linux for a lot longer. So refactoring and going there is a definite benefit. So these are the things we look at as we look to modernize. But the stuff I covered first, the lift and shift and the networks, all that, it's everything you need to do that regular enterprise work. It's everything you've done on premises already. So, there's no new things you have to learn there. The only thing is to leverage that AZ availability is kind of nice. When we look at optimizing, there's a lot of different things in the compute, right? And on the left side, we have the, similar to on-premises. On the right side, we go to the serverless. There's serverless not just in compute with Lambda or Fargate containers. There's also serverless in DynamoDB tables. So if I can switch to that database, that makes a lot of sense. It's not a relational database, and so sometimes it doesn't make sense, but a lot of our programmers use SQL Server just to store key value pairs, just to store config data. And if they're doing that, going serverless is not only a lot less expensive, it's a lot more scalable and can actually scale horizontally where SQL Server can't, without you sharding the data yourself. Another area is S3. S3 is a serverless storage area. So anytime I'm doing app stuff that I can actually move the data to S3, that's great. But there's downsides too. S3 is not as fast as your EBS storage. But I can use and store at 2.4 cents per gig per month right now, petabytes of data rather easy. Try doing that into your SQL Server, right? So as you look at these things, I always try to start with serverless and then work my way back as I look to modernize. Now, what's so great about serverless? It can be factors of times less expensive. And here's a slide that we often show, which is, just on a website. Standard website with about 16,000 users hitting it a day at an average of 200 milliseconds for the custom response. It costs about $3 a day to do reserved instances, lower pricing on that, of instances to handle that, versus about 5 cents a day to do it in Lambda. And the reason is because there's times it's sitting there doing nothing. And on Lambda, you're really paying nothing. And with an instance, you're paying for that instance, even though it's sitting there just waiting. There are times where that's not the case. So you do have to look at your business case. This is not always the case. Sometimes Lambda can be more expensive. I will say it is always more agile. It's always, all you're storing inside AWS is your code. And so your pipeline and your change and revving in the middle of the day, all that stuff becomes really simple if you go there. So that may not, the cost may not be all that important. But that is a thing to consider. Serverless sometimes great, sometimes not. But it does give automatic scaling. You never pay for idle. It's highly fault tolerant. And there's no patching, no provisioning. So some of the great things about the serverless environment. So in summary, what do we do to move our enterprise workloads, Windows workloads, to AWS? Exactly like you do it on premises, exactly like you do it when you move to a remote data center. But do take advantage of those availability zones if that makes sense for your business, because that is a huge, huge difference changer in your uptime and in your ease. You still take backups, right? And taking a backup is as easy as take a snapshot, writes it to an S3 bucket. You'll still take those, but the chance of ever needing to do the restore is a lot less when you're doing the multi-AZ. All right, that brings us to a close for today. We do have more sessions on Windows and that get into some of the deeper aspects. For example, .NET from the ground up on Thursday. We have developing serverless .NET Core, CI/CD pipelines, modernizing legacy .NET applications, and converting monolithic .NET app into a modern app. There are more sessions that happened earlier, and those will be available on YouTube for you to go through. But these are sessions you may be interested later this week. And with that, we're going to call it, but you can come up and talk to us if you're interested and have questions. Thank you.